Multiply them by 100. No, better make that 1,000. And you begin to get an idea of how important mechanical engineering is in this chemical company. Another important phase of mechanical engineering is plant design, layout, and construction. Most companies use outside architects and contractors for this work, but DuPont does all its own. Often the engineers who supervise the construction of the plants also stay on to help get them going. Of course, the design of services to go along with the buildings and machinery is included in their activities. For instance, this nylon manufacturing plant. These ducts are part of an air conditioning system DuPont mechanical engineers help design. During the manufacturing process, air is required at 5 separate temperatures and humidities. That's right, 5. That sort of a problem interest you? As you can imagine from the size of this compressor, air conditioning is a pretty important item in many of DuPont's 70-odd plants. Or say you were tackling this problem, scrubbing carbon dioxide out of a gas mixture. These towering scrubbers work at about 400 pounds. The pressure at the scrubbers forces the solution up the side of a mountain. Here in this tower, the pressure is released and the carbon dioxide passes off to the air. The natural fall of the water gives 200 pounds of head that doesn't have to be supplied when the water is recycled. That's both equipment and plant design in a big way. Speaking of design, how about control instruments? That sort of work interest you? They are very important in plant design, and the advances in this field have been tremendous. Matter of fact, control instruments today are practically a must for nearly every phase of manufacturing operation because they've come to mean so much in terms of safety and economy. Take a look at this maze of pipes, for example. To get maximum production yields, reacting chemicals must be brought together under conditions as nearly ideal as possible. All steps in the process must be smoothly coordinated. Actually, some processes of today couldn't operate with instruments of 10 years ago. It's a fast-moving, intensely interesting field. If this kind of work appeals to you, whether you tackle it from the plant design end or from the development end, instrumentation offers tremendous opportunities. Still another field for mechanical engineers at DuPont is plant engineering. This is a fairly broad field, including maintenance and power. It also includes design and construction on sub-major projects that may involve process improvement or plant expansion. Nearly all chemical manufacturing operations must run in mechanical equipment: tanks, kettles, presses, pumps, valves. And this equipment gets heavy use, much of it on a 7-days-a-week basis. It's bound to wear out, and that means maintenance. Part of maintenance is keeping equipment in top mechanical shape, catching trouble before it catches you. Supervising this work calls for real ingenuity, and it involves real engineering ability. Then there's the maintenance of pumps, gearboxes, automatic lubricators, and a great variety of complex equipment and process machinery. Here again is a supervisory job for alert engineers. Helping with the maintenance work are the machine shops at many DuPont plants. The needs of some of these shops are always changing. That means an almost continuous program of mechanical study ranging from layout and scheduling to working up shop standards. Now, let's say your major interest is power. Power is as essential in a chemical plant as it is in any other kind. And the power problems that arise from some of DuPont's complex operations are about as challenging as can be found anywhere. Power engineers at DuPont must supply steam, electricity, water, air, refrigeration, and other services under a variety of conditions. Look at this steam-reducing station. It is one of several operating at various pressure differentials. They supply steam at the right pressures and temperatures over a wide range of capacities, from 1,000 to 20,000 pounds per hour in short periods of time. Boiler feed water pumps, compression distilling units, fuel pumps. Almost all power plant equipment needs plenty of engineering know-how to avoid interruption in these essential services. Production supervision is another major activity at DuPont. for engineers who like to work with people but still want to put their technical training to good use. The duties are broad and cover all phases of plant operation. Such a job might well include setting up efficient maintenance schedules for equipment, keeping production rolling, maintaining quality, reducing waste, and at the same time, building employee morale. Quality production is determined by individual workers. Each must understand the importance of his job, and it's up to the production supervisors to develop this understanding. The mechanical engineers and others who advance in this work train both wage roll and professional employees in manufacturing processes and the use of equipment, an important responsibility. They also work with development engineers in plant technical sections and the central engineering department. Here their knowledge of the manufacturing process is used in working out designs for process improvement or new plants. In all cases, the planning and conduct of a continuing program of training in safe working practices is an important part of supervisory work. Raw material scheduling, quality standards of intermediates and finished products, handling employee suggestions, all are part of the work in production supervision. The Mechanical Development Laboratory is evidence, too, of how important mechanical engineering is at DuPont. A principal activity of the laboratory is to develop and build full-scale automatic machines to be used as models for those in manufacture. The Wilmington shops are still further evidence. They make special equipment and machines for company use. They are among the most completely equipped in the country, and it's all top-notch equipment, ranging from small bench lathes to large diameter boring machines. Notice that this radial drill press has built-in pits for deep drilling. And how often do you see a 50-inch magnetic chuck? Makes possible the grinding of filter press plates and frames. Here's something else, a 12-foot vernier gauge that, in spite of its size, is as accurate as the best of the smaller ones. This optical comparator shows up errors on machining as small as 2/10,000ths of an inch. And here's a micro drill that puts holes in hard metal so small that you have to use a microscope to get a good look at the hole it drills. Yes, a mechanical engineer has quite a bit of elbow room around here with all this equipment to serve him. Now that you have an idea of what does go on in a chemical company, you can see that instead of no opportunities, a mechanical engineer has many opportunities to use his abilities and training, and in many fields. Because DuPont's 10 manufacturing departments operate to a large extent as 10 separate companies, the way a man heads towards his goal varies from department to department. You might start off working with a man who has had many years of practical experience. You collect material, assemble data, make calculations. In other words, learn the ropes. Gradually, you'd take on more and more responsibility until you've had enough experience to size up a problem, develop a method of attack, lay out a schedule, determine costs, and see the project through. In short, be on your own. In the manufacturing end, DuPont has several types of training programs. You may begin on an informal basis in a plant, as with some departments, or you may attend a formal training program that includes conferences on leadership, procedures, employee relations, company policy, and safety. In either case, you have every opportunity to get a broad picture of the company, as well as to learn your job. But regardless of which way you go, you'll find vast sources of information for your use. Fine libraries with technical, trade, and patent literature. Over 100 engineering consultants within the company, each an expert with years of experience. Metallurgy, stress analysis, power, lubrication, instrumentation, yes, even meteorology. At DuPont, there is a never-ending need for better machines, better ways to do new things to meet the challenges of the future. Research and development, design and construction, production supervision, and all phases of plant engineering unite to meet these challenges. Mechanical engineers work with each other and with specialists of many other fields towards a single objective: better living for mankind through new ideas, new methods, new products, and improvements on existing ones. There are many opportunities to contribute to this objective, and while doing so, there is the opportunity to express your creative talent and ability, to accept real responsibility, whatever your field of training. Yes, in such an environment, you can look to a bright future with confidence and optimism.